and explain what all these answers mean. You don't need to calculate any of these answers, you need to explain what the answers mean, and then I've got some new calculator skills to show you. Okay, ready, set, go. It's all right. I'm going to be really picky about things like units. Super picky. One more minute. All right, let's pull together. For part A, hopefully your answer is something like at time t equals 3.2 seconds. What do we know about the rocket?
It is 97.16 feet.
The height of the rocket is 97.16 feet. Maybe you said the rocket is 97.16 feet above the ground, something like that, okay? All right, part B, dw dt is notation for derivative, right? So I'm gonna write this sentence. I'm gonna start over here at the time. At t equals 3.2, what do we know about the rocket? At t equals 3.2, Stephen, what do you know?
Has a instantaneous velocity of -22.4.
It has an instantaneous velocity of -22.4. Do you have units for me?
Feet over second.
Feet over second. I like that. I think another way, a safer way to write this is, are you in AP Physics?
Yes.
Okay, that's fine. A
Well,
safe
what?
way to say this, At t equals 3.2 seconds, what do we know about the rocket? W represents the height of the rocket. At t equals 3.2 seconds, W represents the height. So I'd say like the height of the rocket, what's it doing?
Decrease.
Is decreasing at a rate of 22.4, and then I come over here and I look at the units for W, feet, units for the denominator, seconds. So at t equals 3.2 seconds, the height of the rocket is decreasing at a rate of 22.4 feet per second. If you're in physics and you understand that the derivative of height is we're really talking about velocity, that's okay too. But be really, really careful. Really, really careful. In part C, W prime, also notation for derivative. So at what time are we talking about here? At 2.5. At time t equals 2.5, what do we know about the height? At time t equals 2.5 seconds, the height is... It's at its maximum. You could say the height of the rocket is constant. It's not changing. If I think about the rocket, I fired off the rocket, it's at its highest point, and it's on the way back down. Everybody okay? All right, I want to get you some new calculator skills that might impress your friends. All right, so if you guys can take out your calculator, and what I need you to do is type in the function w of t into your calculator. Let's see what happens with that. Your calculator knows about derivatives. And I want to make sure that you know your calculator knows about derivatives. So, here we go. Oh, killing me. That's because I didn't plug in. I thought I could. And there we go. All right. So you've got your function graphed on the screen. Everybody okay with the graph?
Yes.
Oh, Celeste is having some problems there. So maybe somebody can help her out. So menu, graph. I want to graph a function. Now you got to be careful. I know it's been a while. Negative 16, not t squared, x squared. Your calculator only works with x. Now, this graph is okay. I don't really like this graph because I don't get to see like the maximum point. I know that this is an upside down parabola. So let's change the window. Anybody find a good window? What's a good window on this one? I want a window that's going to give me the whole graph.
Y max is
Negative 2.
Y max is negative 2?
Wait.
10.
Wait, no.
10.
400.
Yeah, we're going to need something bigger than that. So if I go to Windows Settings, I heard 400?
Yeah.
Okay, that's way big. Okay, like maybe I could have gotten away with something a little bit smaller. I don't want to obsess too much over the window. I just want to make sure that I'm seeing all the important things on this. So maybe like 150. If we're being realistic, I don't need to worry about any negative x values. So maybe I want to go from 0 to 10. Everybody okay? Okay, according to our calculations, W of 3.2 equals 97.16. The way that you can confirm that this is right on the calculator, menu, you can go to trace, graph trace, and let's just type in 3.2. I'm getting 97.2. I think I'm having a settings issue. Okay, is everybody good at 97.16? Really awkward.
Yes.
Yes.
Giselle, you're okay with 97.16? I like 97. Everybody's got 97.16. That's nothing new. Okay, new stuff. Menu. Analyze graph. Anybody see anything helpful? Anybody see anything that might
dy
change
over
your
dx.
life? Steven?
dy over dx.
dy over dx. What the heck does that mean?
Derivative.
Derivative. Look at part B. It says that the derivative at 3.2 is negative 22.4. Just type 3.2. Negative 22.4. By hitting derivative, it'll tell you exactly where the point is on your calculator, and it'll give you the exact value of the derivative. And hopefully we're not surprised that that derivative is a negative value since the function is decreasing. Myra, are you okay with that?
Yes.
Are you in love with the calculator now? Okay, let's make sure part C is right and I'm not lying to you. Menu, analyze graph, dy dx again. This time find the derivative at 2.5. We're getting 0.
Yes.
Okay. Your calculator knows how to find derivatives. It is a beautiful, beautiful thing. Everybody good? All right. So what I want to do is, if you guys flip over to the back, we're just going to call this a challenge by choice. That's going to be the end of the calculator stuff for today, so if you want to put it back, that's fine. For those of you that want some practice with derivatives and good notation, that's what's happening on the back here. Challenge by choice, we've got a little bit less than 10 minutes. If you want to just work on this problem, the one on the back, and you're like, hey, I think I'm in a good place with this, feel free. If you want to work through a couple of these parts with me, if you could move up front and then you can just, it'll be me, the friends at North Central, and anybody that wants to sit over here. And if you want to move because you don't want to talk to me, feel free. Is everybody just going?
This count as talking to you?
Like, I'm only going to focus on the friends that are over here and the friends at North Central while we talk through this problem.
Okay.
If you're on this side of the room, I'm assuming that you are fine. You're going as far as you can with this problem and maybe getting some help from peers. But if you want my attention, you're moving over to this side. You guys are good where you're at? Okay. Friends in the back, are we all okay? So it's just the three of you, me, and 5 or 6 good-looking people on the other end of the camera. Or at least we're assuming you're good-looking. We don't actually know. Send us your pictures. All right.
Wait.
All right, so friends over here. The height of the Mavericks rocket can be modeled by that function negative 16t squared plus 64g. T represents time, measured in seconds. Rocket was launched, and m of t represents height. Determine the value of m prime of 3. What are we going to do? I want m prime of 3. How are we going to find that? I want to be really careful about how we're going to set this up.
That's you.
Plus. Right, we know this is the derivative. So what's the formula? There's 3 choices here. There's like 3 different formulas you could use. If I want to find the derivative at just one little point, one of the easier ones is that like f of x minus f of a over x minus a. Be careful though, you got to make sure you get all the right variables. Okay, so what's the setup going to be polynomial?
Mx plus a.
Well, I want to be careful. It's m of t.
Oh. It's n plus 3x plus t.
Ooh. How about like m of t minus m of 3 over t minus 3? Right, think like slope of secant line. Not good enough though? You need that limit. What's that limit going to be, Allie?
As t approaches 3.
Limit is t approaches 3, m of t minus m of 3 over t minus 3. At that point already, I get to award you a point. Like, check. Great, now let's keep going. limit as t approaches 3, m of t, what's that, negative 16t squared plus 64t minus, now I need m of 3. Negative 16 times 3 squared plus 64 times 3. We're going to have to do a little bit of work there. 3 squared is 9 times negative 16. Was that negative 144?
Oh, this is 6 times
64 times 3 is 192. I think all that stuff over there is equal to 48. All right, Giselle, what are your thoughts here? What are you going to do next? Okay, do you see something that you can factor out of all three?
I'm an idiot. So 4.
Okay, 4 for sure. 16, 64, and 48. You can also take out 8. You can also take out 16. 16. And if I really want to make my factoring life easy, don't take out a positive 16. Let's take out a negative 16 so we can just get that negative out of there. So now I've got negative 16 times t squared, what is that, minus 4t plus 3 over t minus 3. Some more factoring we can do here. T squared minus 4t plus 3, I think factors is t minus 3 and t plus 1. And those guys cancel. And hopefully that's not a surprise that the t minus 3s are going to cancel, because that's what's giving you the 0 over 0 problem to begin with. So take the limit as t approaches 3, and we're going to get negative 16 times 3 minus 1 should be negative 32. I'm going to go check in on the friends over there. What I want you guys to do before we move on to part B, give me the sentence. What's the sentence that you're going to use to pull all of this together? How are you doing over here?
How is it 2 minus 1?
Did you factor in a negative 16? So it's t squared minus 4t plus 3.
What would that be? T
When you
squared
factor,
minus
you get a positive 3 here. Those two numbers are going to
Oh, yeah.
It should be a positive 3 if you factor out a negative 16. Right, but you're factored, wait. The mistake made the other day. So m of t minus m of 3. So it's this minus 48.
Oh, right, in the basic equation, right. The basic equation. Yeah, because the basic equation is f of x minus f of
Okay,
x.
there is one. Yes, there is.
That's the basic equation.
Or 3 sentences.
No, it's right. It's just when you get.
All right, Alderman, how are you going to start your answer for this one?
We did it minus 3, so plus 3 next time.
At t equals 3 seconds. Yeah, keep it coming.
It's just because when you
The
say
height
it's
of
the
the
basic
rocket.
equation, you have to put a minus. When you put a
It's
plus, you put a
decreasing.
minus.
T minus
Is
3.
decreasing.
You put a plus.
So
instead
when
of
you
minus.
factor it out,
I mean, 32 feet.
Oh, you're saying when you factor it out?
At a
Yeah, right
rate
here. So it can be plus 1 because it'll still come out
Of 32. Now I need the units. Gotta get this right.
Feet per second should be.
Right, it's the units for the
so is it
dependent variable divided by the units for the independent variable.
Negative 32.
You guys doing okay?
Yeah, because now you have.
Alright, so that's part A.
Understand.
Done, got it locked in. Part B, I want to determine the value of m prime of t. Stephen, if I'm writing over here, are they able to see?
Now they can.
Okay, now they can? Alright, m prime of t, right? What's different now, I want to know m prime of t when the rocket returns to the ground. What do we know if the rocket returns to the ground?
Then
Yes, it is.
the total
It's on the board.
MT.
Okay, so when rocket returns to the ground, that means that m of t, which we know to be negative 16t squared plus 64t, has to be equal to 0. So you're going to have to figure out first, what time does the rocket return to the ground? Second, what's the value of the derivative there?
T.
Height of the rocket increases at a rate of
Oh.
negative 32
Right.
feet per
Oh, you do it again.
So this is a negative 3.
You've already used the decrease. You've already said decrease. Don't use the negative again.
Not, you can take out T as well. It should be like T, like, T plus so.
This is our
This is right here.
this.
T with
This is T, and then negative 16.
It comes out to this, right? Negative 16. Comes up to this. This far over here.
So if m of t is equal to 0, I'm getting that t is either equal to 0 or t is equal to 4. So what time does the rocket
Right,
return to the ground?
And just 16, T.
Oh.
Is it 0 or is it 4?
value of You said it equal to 0?
We need to work through
What
both.
mistake I made up there?
We set the first equation.
Yeah.
Why does it always feel like I don't have enough?
Go back and read the problem. The question is, at what time does, what's m prime of t when the rocket returns to the ground?
Which is 0.
Not 0. Returns to the ground. At time 0, you have launched the rocket and it's going. Right, so really I'm gonna ask you the question, what's m prime of 4, and you're gonna take it from there. Alright friends, I'll see you later. Get that journal entry done tonight. It is a long one. The notation is gonna be killer. Be careful. I'll see you at 1:30.